everybody, it's me, Ladyada, here at the Adafruit factory at the end of a busy week of electronic engineering, software, and debugging. And I'm here with new best friend, Mark Garrison, visiting from New York from San Francisco Bay Area. Traveled all the way here for some reason. I'm going to selfishly say just to be on this show.
Well, it is definitely one of the highlights, if not the highlight of the trip. Well,
you're the co-founder and CTO of this company called...
So it's pronounced Saleae.
Saleae. Ooh, I've been saying it wrong all this time. Saleae. Okay, so why this name? So many vowels.
Yes, it's a good question, actually. So we started working on logic analyzers in 2008, but the name Saleae came in 2005 when my brother and I were working on other miscellaneous side projects, and we needed to have some sort of legal company entity just to like fill in the company line.
You're like, I need an EIN. What do I put in? Okay, so.
And so we didn't really know. We were working on some random project, but we knew that we just needed a company for any kind of project we were working on, completely unrelated. Exactly.
Okay.
And so the requirements were the .com domain name needed to be available.
Yeah, important.
And we needed, I'm not actually sure where it came from. Joe says it comes from the periodic table, the element selenium.
Selenium, okay.
And we found the sound Saleae, and we really liked the sound of that, but we couldn't for the life of us spell it.
Good enough reason. So Saleae is how you say it. And everyone knows your product for like the last decade and a half. You've been making logic analyzers. And now some oscilloscopy type logic analyzers. But logic analyzers have been your bread and butter.
Right. And we got into this, let's see, my brother and I are both electrical engineers.
Yeah.
He was working on a different hardware product back in...
Come closer. Yeah. I know it's fun to lean back, but the mic's here.
He was working on a different hardware product and needed a logic analyzer. And we barely even knew what a logic analyzer was because they did not introduce that concept into school.
Yeah.
And you don't really see it very often.
Yeah.
But we knew that we needed tools to help debug firmware. And there's the same problems over and over again where you have your microcontroller, you have your wireless module or your sensor.
You're sending some bits, but then you're like, am I really sending these bits and how fast are they going? And you can't trust anything.
Exactly. And most of it is just guess and check. Maybe you slowed the clock down as far as you can, or use a voltmeter to check the signal, or maybe you're stepping through the firmware and you're just trying to figure out what's broken.
Okay.
And so we had, let's see, we have a couple of them lying around the office now, but we managed to buy the cheapest logic analyzer available.
Yeah.
And it made things about 20% better.
Okay,
good. Like, now instead of fighting that problem, we were fighting the other tools.
Yeah.
And so I think probably...
You broke your tools with your tools, and now you have no tools.
Yeah, exactly. And the concept is simple. We just need to record some digital signals and put them on the screen. And
kind of hard, though. Not that easy. Like, it seems like it would be easy, but it's actually kind of a challenge.
Yeah, and the hard part is, I think, once you have the data there, like, what do you do with it? How do you make that, like, a great experience for people to actually find what they're looking for, sift through large amounts of data, kind of use it all the time, reduce the barrier so that instead of hauling out some large,
traditionally logic analyzers were like, they're oscilloscopes, essentially. They're just big-ass things with CRTs. That's what we had in school. But you're like, we have CRTs on our desk already, computers.
Yeah, and later on we ended up buying from a friend. It's like an oscilloscope from 2008. That's a built-in logic analyzer, and to this day I haven't been able to figure out how to make it work.
Yeah, challenging. But people like the Saleae logic. In fact, some people might be wondering, well, what does this thing look like? Well, we have one here that maybe you could point out the features of this black square.
So the basic idea is that a traditional logic analyzer, everything's in one. The screen, the inputs, the data processing, the storage.
Yeah.
The idea for all of our logic analyzers is it's just a simple USB device.
Okay.
And so you can see on the back, we have a little USB port.
So this is classic. So I have a USB mini, but they don't have USB mini anymore. Right? I think you're micro B. But this is like, you said it was like OG. It's like old one. It's one of the first ones that came out.
This is the Logic 16, and we shipped this thing, I think, on my graduation day from college, actually.
Oh, yeah? It's a good graduation present.
It was a lot of fun. The big thing is it has 16 digital inputs. So just for context, we can actually wire this guy
Okay, so this is these are the input ports, and this is the output port.
Right.
Computer. Okay, so then to this side, you connect.
Right, so you have these little wire harnesses.
Okay.
And they just plug into the front. And the general idea is you're working on some sort of a circuit board or a series of dev kits or a breadboard, and you just want to hook up little clips.
Okay, so this is your ground, and then this is 9 pins because you have ground and then 8 different colored contacts.
Yeah, and so the general idea is use these clips, for better or for worse. We'll see which ones
Those
these
are pretty nice clips. You know,
The,
they're. Oh, can you show the tip?
Oh, there we go.
Little
Yeah, I
springy?
should look at the screen, shouldn't I? That helps
That's
a
okay.
lot. So the general idea is you hook up clips like this to the circuit board you're working on.
And then,
Perhaps
yes, look, there's a
this
circuit
one
board over
right
there.
here.
Maybe I want to debug this SPI flash.
Yeah,
So
so
then you
this
would-
is really convenient because that SPI flash chip is just big enough to clip, and maybe it's a little bit too big.
Oh,
but a
no,
little
you
too
got
small,
it.
But
Okay, so you can connect one to every one of those 8 pins.
Yeah.
And then on your computer, while you're running the firmware on this chip, the data comes out. And
Yeah.
it looks a little bit like this simulation here, which we pre-recorded. This is not actually us. Okay, sampling. And does it do real time or it's after the fact?
So what you're looking at right now is after the fact. The idea is you press start, you record for a amount of time, and then it stops or you manually stop it, and then you kind of review what you're looking at.
And usually you can find where because it's hard to actually stop and start, like the data's coming back and forth so fast, a human can't look at it anyways.
Yeah, and so for digital data, we do actually have real-time view for analog and digital, and we'll talk a little bit more about that in the future. But for digital data, usually what you want to do is you want to record quite a bit of it, and then that gives you all the context. So you're not just looking at a little blip of what's going on. You're actually seeing from the moment the chip powers on to the firmware is loaded. We start initializing the other components. We start routinely recording signals or routinely writing to memory. You're trying to pair over Wi-Fi, that kind of stuff. You get
Yeah.
all the context in one place. Now for analog signals, which this product does not support, the current products, Generation 3, have analog inputs, and the way we like to think about it is it's a logic analyzer with analog data recording built in.
For like your power supply perhaps, or
Yeah.
like a bias voltage that you're checking. It was not, maybe it's good for like if you have a DAC of some sort, but it's not an oscilloscope the same way
Right.
that a desktop oscilloscope is.
Yeah, it's got a 5 megahertz bandwidth limit. It does not have variable gain and shift, and it does not have any of the other oscilloscope features like a real analog trigger, which is used for the real-time display. It doesn't have like the fancy features like 50 ohm mode or
Or like
AC mode, that
FFT,
kind of
but
stuff.
it could be good for like, you're seeing your chip is failing and is it like the power supply is drooping, which does happen. Like sometimes you flip all the bits or you tell it to go and your chip goes into a certain mode, the chip comes up, it sucks a bunch of power, the power supply dips, and then suddenly it stops working. So that could be really handy.
Yeah, stuff like your I2C lines, like how's these pull-up resistors working?
that's
you
a
can look
good
at
point.
the nice slope on that.
Yeah,
you can
yeah,
measure
yeah.
if that's really
So you see the
kind of
digital
things.
signal, but maybe you're like, okay, I see the digital, but I also want to know what is the transfer
Yeah.
function, or if there's ringing, is that what's causing problems,
Yeah.
like termination issues?
Yeah, and so it helps for low-speed applications like that. Also, it has lower analog sample rates, which allows you to record for fairly long periods of time, and that's something we really want to improve in the future.
Yeah.
But let's say if you wanted to measure, temperature or the voltage droop of a device as it slowly drains, that kind of stuff, you can actually, go.
That's true.
Go grab a coffee and come
Yeah.
back and use your recording.
Okay, so this is the old one, but the new ones, they have analog, but the thing that your big thing is the software. That's like and we showed that briefly. So let's actually look at the team of folks that you have here. So is this really all the people you've got right now?
So that photo is a little bit old. So we have a couple of consultants and the contractors, one full-time graphic designer just not in that photo.
Who are these wonderful
it's
people?
Tiny. So we have Oz in the back left there, Christina, and
Wait,
then
you have like the same shirt on.
no, actually, so I
Similar.
own about 11 different Machine T-shirts.
Okay,
last
so
time I counted.
so people know you when they see the cat.
Yeah, well,
you.
my friends do.
Okay.
And I think in technical customer support, if you contact me, you will see a little Machine icon eating pizza or something like that.
Okay. Well, this one's reading a book. Okay.
Tim is actually, he's an electrical engineer too, and he also runs like technical customer support.
He's got the blue jacket on.
Yeah.
Okay.
Oh yeah, sorry, no one can see where I'm pointing here.
Yeah.
Then myself, when my hair was still dyed, and Deborah, our operations.
She's got the pink shirt on.
Yeah, she
sweater.
runs operations.
Okay, who's the fellow in the cool leather jacket?
So that's my brother Joe, and
Okay.
he's 9 years older than me, although for some reason people can't tell. That's probably good for him.
Yeah.
But so he has actually been working on different ideas, different like company ideas since he was a small kid. Like,
he's the entrepreneur.
Yeah.
He's like the Steve Jobs
Like
of
he-
logic analyzers.
Well, that'd be awesome. But I think he, like when he was young, he was actually like trying to sell popcorn, like door to door, like he'd pop popcorn. And for a while, he was like buying like audio equipment, electrical audio equipment that had broken down off of the classifieds in the newspaper, trying to fix it and reselling it in the
Yeah.
classifieds to try to make money that way.
Okay. He's a hustler.
Yeah, and once he got into electronics, it was just like, the world is my oyster.
Yeah, because now I can fix any stereo system and resell it. And then he got you involved.
Yeah, and so he suckered me into it when I was in high school with dreams of like, getting rich and building cool robots and that kind of stuff.
Okay.
But I think, let's see.
They don't talk about things like making payroll and dealing with like 401k contracts. There's always getting rich and making robots, but there's a little bit more of that.
Yeah, and we built a lot of cool stuff, and it was a learning experience because we both grew up in Arizona. We had really no exposure to like what other people who have done this before, or venture capital, or any of those sort of things. And so we kind of just making it up as we went along. And as classic introvert electrical engineers, we just, it was us, the internet, and like what was available in our apartments, and not really like, let's go out and ask people how they did it. And that kind of
you just kind of did it, which I remember when the first Logic ads came out, and I was like, damn, these people are very aggressive. They're like, this is our thing. We're offering this one item, but it does it very well, and this is the software. And at the time, software for electrical engineers was like a very dirty word. Like, having good software for tools was considered a waste of time. It was like, well, you should make the hardware good, and then the software is just some like crummy command line tool that only runs on like Windows 9X or something.
Yeah, that's the worst.
Yeah, it's the worst. And you and I have experienced that. It's like, oh man, how did I get into like TI MSP 430 like development kit? What destroys your computer. I once installed OrCAD and it actually like destroyed my computer. And I think what was neat is to see this very fresh take. I think being outsiders is really valuable, right? It's like you're like the Smith & Wesson of logic analyzers. Like, you didn't know what was expected, so you're like, well, we're going to make something that's good for us.
Exactly.
And what's good for you is actually good for everybody.
Fortunately, it worked out that way because it was really just a problem we were working on, and we needed it. And the original logic analyzer, I think the thing we were actually selling had like 35 parts on it.
Yeah.
So it was like hand soldering these things together, like in the little tiny cubicle he was renting at the co-working space.
Yeah, it's class. I also worked with the Cypress FX at the time, so I was like, I know this chip.
It's the worst chip.
Weird ass USB driver loading through the drive thing. A nightmare. But it's the cheapest, fastest USB chip you could get at the time.
Absolutely, and it is basically a logic analyzer in a chip. It just has a parallel bus on the one side. It's configurable, either 16 channels or 8 channels, and ability to stream it with a couple different stream control modes. And
what's neat is I'm not the only person who thinks that your stuff's really great. Your reviews on Amazon, we took a screenshot from your site. You're proud of this.
Thanks.
Pretty sweet.
So now I have to say this was not live updating when you took a screenshot of it, so I'm not 100% sure exactly.
I hope every day you're like, exactly what your percentage is. That'd be cool.
So actually, the current alpha software, you can leave feedback directly in the app.
Yeah.
We've always had that link in there, but now it just a little pop up, and you can send a message, and then when you press that send button, it just shows up in my Slack immediately.
Oh wow, that's pretty interesting.
If you're just like, hey Mark, what's up? Now I might not see it right away because I do have that channel muted. But
no, because it's like 3 in the morning. You don't be woken up by like, hey, what's this button do?
Yeah, so trying to collect feedback is like the main thing we're doing. Just to tell you a little bit about the software situation, we've been selling.
Yes.
Our products have used the same core software since 2009 technically.
Yes, which supports Mac, Linux, Windows, so people love that.
And we've been sort of building features on top of that, and at some point we added analog
things, it's analog. Yeah, okay, so this has become like a big morass.
Yeah, and thank goodness people like it, because somewhere in there is Mark's first C++ code.
Okay.
Like, this is kind of a project that's like a patchwork of code, to the point where we felt this a lot internally, is that feature development slows down because 20% of your time is adding some cool new feature, and 80% of your time is trying to make it work inside of the rest of this sort of the situation you built yourself into.
Yes.
And
the technical debt.
Exactly. That's exactly what it is. And so learning it kind of the hard way about like, okay, maybe we need to if we want to make Saleae great, and we want to take this software and just kind of keep building it into something that I don't know. When I look at it, I just mostly see the things that I want to improve now. But if I want to actually make the dream of building just a beautiful application, it's easy to use, works extremely reliably, which is a really big component of that, we need to look at how we actually do this. And so at the beginning of this year, we started a new project, and the whole point of that project was how do we actually add real-time?
Does this project have a code name?
Let's see.
Or is it called The Project? Is there a name that you can't say because it's like not okay to say on TV?
There's a lot of words. So Graph.io is the name of the back-end data processing system,
Okay.
Which is a complete separation from the UI.
Yeah.
So the idea is that now the process of recording it, transforming it into a memory, for like basically compressing it, how to render it, it's a very hard CS problem. And so we've been focusing a lot of effort.
There's a
on
lot of
making that
data.
high performance. Yeah.
Like it's easily you can get like 500 megabytes of data. It's trivial.
Yeah, we have customers that are buying 64 gigs of RAM for their computer and SSD so that they can run over the 64 gigs of RAM and
Yes.
still be recording it.
Yes, because you're sampling at huge rates.
Yeah.
So it's like even if your signal isn't that fast, because you're sampling. I mean, this is why you should always set the sample rate to whatever that matches. But you may need to be capturing incredibly fast data for over a few minutes at a time.
Yeah.
Boom.
And if
And you can't transfer. It's like you may not be able to transfer that streaming. Like you actually might have to you have to send it all at once.
So that's actually one thing that we there's kind of two categories of logic analyzers.
Yeah.
Ones that stream it all the time over USB, and
Yeah.
then ones that just record it, buffer it, and then send it over.
Yeah.
And we are completely in the streaming only camp.
You're only streaming, but what happens if there's some there's some busy
Issues. Yeah.
data
So let's
or-
say you plug in your webcam or you start copying your favorite
Or
tunes. off
people
of a
don't
USB
realize their
drive.
hard drive is on the same
Yeah.
bus. Then what?
Then you get this lovely error message that a small percentage of our customers, that's the pain of our existence. That's like,
yeah.
I'm sorry, but Logic was unable to keep up with this sampling rate.
Yeah.
And we have USB 2.0 and 3.0 protocol analyzers to look at the timing of that, trying
Yeah.
to figure out what layer is things going wrong. We have USB host controllers, which is the part of your PC that talks USB. We have
Yeah.
one of those from every vendor. Which we tested across, Windows. Thank goodness we're dropping Windows XP, but
Oh yeah, no,
Windows
you
7.
gotta kill that. I would kill Windows 7
Windows
too.
10.
Actually, I tell people with Windows 7, I'm like, it's been 10 years. I'm sorry.
Is it really?
It's been 10 years.
Wow.
Move on. It's now Windows 10 is quite good. Move to it.
Yeah. So the
Sorry, folks. I do get sometimes Windows XP people, and I'm like, look, that's 20 years.
yeah. So speaking of being stuck with older software, we have a lot of larger companies that buy our products, and they're
Yeah.
almost exclusively on Dell Latitudes. I know,
Oh, totally.
I know every Dell Latitude, which version of the USB driver shipped with that computer, because Windows 7 didn't have built-in USB 3 drivers.
Well, but wait a minute.
Which one needs
You can
updates?
barely even run CAD software on those. I'm kind of surprised.
Well, I mean, you can buy a brand new Latitude today.
Oh yeah, no, I'm
but,
saying they're not. It's not that the latitudes are 10 years old. It's just that they have. Because I'm like, if they're running Windows 7 Dell Latitude from 10 years ago, you can't run CAD. Eagle CAD won't run on anything slower than 3 years now.
Yeah. Now, we were also troubleshooting this a couple of years ago when we were in the middle of the USB 3.0 problems. But
Yeah.
it's just that's how it works. You just get, here's your company issued Dell laptop. Unfortunately, new ones are now issued with Windows 10. But we still have people
Yay.
that were issued, and they have, this Intel host controller driver is not compatible with our products. You're going to need to install this one. We have other problems where it's already installed, but uninstall it, reinstall it, but they don't have to go into detail.
Isocronous is not quite what they say it is. So if maybe somebody's watching this and they're like, these sound like problems I'd love to solve and work on. There's people like that. Do you guys have job openings and stuff?
Yeah, so we're actually actively hiring 3 positions, potentially 4 actually. The software side of things, we're looking for a front-end developer. We're basically building the new alpha software. The front end is written in React and TypeScript, and it's actually a really interesting problem because unlike traditional web applications, most of our application, it runs entirely locally on your computer, and it's mostly a data visualization tool. And so we have WebGL, we have a lot of Canvas stuff in there, we have a lot of performance issues, a lot of performance tuning around mouse interactions and that kind of
Yeah,
stuff.
because you're able to scan in and out and scroll through, again, megabytes and megabytes of data.
Yeah.
Very
and
fast.
I'm going to try and prevent myself for talking about that too long because I kind of eat, sleep, and breathe that exact problem.
Yes, it's one of those things that it's like, how hard can it be? Actually, very hard.
Yeah. So if you want to solve the problem of how do you actually record data at 3 gigabit and then transform it into a format you can render rapidly, we're looking for a C++ developer to work on the back end of our application. We actually restarted from scratch the back end of our application early this year, try to get away from the the architecture issues of our old software. And this new architecture is completely decoupled. It's actually a little bit similar to GNU Radio or other sort of block-based processing tools where you're building individual nodes that kind of stream data together. And so one node might be doing compression or running an IIR filter to compensate or calibrate recordings. We have storage nodes and rendering nodes and measurement nodes and that kind of stuff. And that's really an exciting project, and that's probably what we need the most right now, actually.
Yeah.
And then we're looking for an electrical engineer. So I don't want to get into too many specifics just because it's a little bit too far out to kind of make any public commitments, but we are looking for an electrical engineer for high-speed digital design, and we're looking for FPGA, HDL skills.
You ditched the Cypress a while ago, and now it's all FPGA based.
Well, we still actually, so we have an FPGA in front of the Cypress jet.
The Cypress just handles the USB, but the FPGA handles all the data
Right.
capture and gets it ready.
Yeah, it actually did all the FPGA development for our current generation of products.
Oh, great.
Which is absolutely loved every second of it, but boy, do we need a hire professional.
Yeah.
Especially if you want to get things done in a reasonable amount of time. So
Yeah. No, you can easily, you're like, how did 8 hours just pass? And I've just made like a flip-flop.
I know, it's like, okay, we finally got the clock divided down 2 megahertz, and I have to go home now.
Day's over.
Or like the Xilinx tools keep crashing on me constantly.
Okay.
But, and so we're looking for basically 2 skill sets, and it might actually end up being 2 individuals, because even if we manage to find someone who has both high-speed digital design skills and FPGA skills,
Yeah.
probably makes sense to actually just so we can do both of those things at the same time.
Yeah.
That's pretty much like the high-level summary.
And you guys are located in San Francisco.
And we're in South San Francisco, just south of San Francisco, as you might imagine.
Nice.
If you want to learn more, you can just go to our Saleae website and click the should be a contact
Dude, you
support
get
up
all
there.
the logic analyzers you can handle.
That's true. They
And all the
obviously-
Latitude
yes.
laptops you want. And then actually, another thing, so we actually want to show, so you guys make 3 different logic analyzers now. You kind of, it's the Logic 8, Logic Pro 8, and Logic Pro 16. So you had like 1, and then you had like 6, and now you're back to 3. So you're very focused now on this is your beginner, intermediate, super express.
Yeah, we actually used to have Logic 4, and if you want one, you could probably contact us. We still have boxes of it. And we were really excited because it was it was actually cheaper than the original Logic.
Yeah.
And we sold almost none of them.
Interesting.
I don't remember
I
how
think people
long it
really
took.
need you need like 6 pins.
Yeah, and when I think when people looked at the price difference between the Logic 4 and the Logic 8, and they said, you know what, Logic 8 has 8 analog inputs, 8 digital inputs, it's 50% faster than the original, and it's just extremely flexible, supports these I/O like voltage modes that the Logic 4 didn't support.
Yeah.
And you're like, you know what, I'm just going to pay the extra cash.
Market
and get
fit
it.
is tough. You don't know necessarily. And so for these 3, one of the things I remember, like 6 years ago, and you mentioned this here, I remember that there was, your company had this, you went through this transformation where you tried to bring manufacturing in-house. And then I remember, I think Joe Poston was like, boy, that didn't work. We're going to go back to outsourcing.
Yeah.
But I think the story is really interesting, and I think it's really impressive that you're willing to admit that didn't work out. Like, we put our manufacturing in-house, but it isn't for everybody. And it could be that it wasn't something that was a good fit for your company. So do you want to tell the story of why did you try this and why didn't it work out, and what did you learn?
Yeah, so since the beginning of the company, manufacturing was always a challenge. We didn't really have any experience with it at all.
These are like nicely
And-
aluminum milled boxes too. These are like fancy.
Thanks. Actually, so one of the motivations for having an aluminum enclosure was that you could actually have that manufactured in low volume with no tooling costs.
Right, because there's no injection molding. You just machine it.
Yeah, and
Okay.
we were building the first units on credit cards.
Yeah.
And trying to find people with a CNC mill in their backyard or in their garage to build
borrow
it.
your Haas. Okay.
The
But then eventually you got too popular.
Well, we're still fairly volume today, or still fairly low volume today. But the third generation of our products is significantly more complicated, and we already had manufacturing issues with the first two products, Logic and Logic 16.
So you were outsourcing it to a partner facility.
Yeah.
Their manufacturing. So what was the problem? Yield, lead time, cost. What was the challenge for you?
So most of the issues with the circuit board assembly. So we would do final assembly at our office. We would order assembled circuit boards. We'd order metal cases.
Okay,
other
and then you do the
components.
final
Yeah.
put together and test.
And so with the circuit boards, there was a combination of lead times, quality control, at one point, one of our suppliers gave us counterfeit chips. Like, it was just a
Dude,
whole
that
mixture of
sucks.
problems.
I've seen that. You have to be careful. You have to, other than that, you have to send them a kit, but then it's like you have to hold all the inventory.
And the core of the problem, I think, is that when you're a small company looking for a manufacturing partner and they don't have very big volumes,
Yeah.
most of the large established players are not interested in talking to you because they're just not going to make that much money off of you per year.
Yeah.
And so you're kind of left with two categories. Best case scenario, you find a new manufacturing company they're actually really good, but they're still growing. They're still interested in small order volumes
Yeah.
because they haven't filled out with large customers yet. Or low quality companies that they just can't get good larger manufacturing
Yeah.
deals.
They're
because
what's
it's all
left. They're
kind
the
of-
leftovers.
Yeah.
Okay.
And so we switched between, I think, 3 or 4 of them, and we didn't have like consultants or anything to help us with manufacturing, so we were just kind
Yeah.
of figuring it out.
Well, you're engineers, so you're like, oh, send you the Gerber files.
And hope for the best.
Thing
And
pops out, right?
and so for the third generation, we were looking at, we actually did some manufacturing in the United States, in the Bay Area, which is fantastic. It does cost about 5 times as much per part to do it in California versus overseas.
Yeah.
And so we were able to do that here and there. But when we started working on new products, Logic Pro 16, our flagship product, has 923 components now.
Oh my God. Is it
and-
like mostly passives or?
And 600 of something of them are 0201s.
Oh, jeez. That
The
sucks.
circuit board, I should have brought one with me. It's a gorgeous circuit board,
Yeah.
black and good. There's
Why,
actually
why
photos
so
on our
many?
website.
So just.
So we have 16 analog inputs,
Yeah.
and you can record all of them simultaneously. And so
Okay.
what we needed was the first stage is called a compensated divider, which you might be familiar with. It just brings the voltage range down with a very high DC impedance.
Okay.
Then after that, we need to go through like a single-ended differential conversion. I believe one of the models has just like a voltage follower buffer before that. Then the single-ended differential conversion goes into there's actually a 6-order low-pass filter in there, Bessel.
So basically, before you know it, you have like 25
Yeah.
components
Per
and
channel.
passives, and then per channel, and then you multiply it out, and then there's 600 components.
Yeah.
Okay. And it's a double-sided 6-layer board or something?
The Pro 8 is double-sided at 14 layers, but the Pro 16, because it has so much more real estate inside, is 8 layers and it's single-sided.
You have
even
a
though it has double the
14-layer
part.
board?
Yeah,
That's insane, dude.
it was 14, wasn't it? I think the final version is 14.
Okay, it's like 1 layer per signal. Okay, so, all right, so you had this 900 component board, and when you went to your local manufacturer, they're like, well, it's 10 cents per component, and you're like, this thing is going to cost us $90 to assemble.
Yeah, in fact, it was 6 cents per component.
Yeah.
And it was like, wow, we
You can't do that.
and like the price point required for this thing to actually make any money is kind of ridiculous. And
Okay, so then you're like,
well, it was a big conversation between myself and Joe, and we thought that we were going to try in-house manufacturing for the actual circuit board.
okay,
And so we start shopping around. There's this company that I'm actually not going to mention, but they have
Encore.
like sales consultants people
Yeah.
that will like try to figure out what your needs are and kind of design a system for you.
Yeah.
But ultimately, we ended up getting a pick and place machine, dual head. I think it was 5,000 parts per hour.
Yeah.
And a vapor phase reflow oven.
Yeah.
And just like a manual stencil printer.
Dude, you manually stenciled for 0201s?
Yeah, and so
Damn.
there's this effect called tombstoning, which
Yeah.
you probably know far more about this than I do.
You're going to get the smaller the part because there's less mass. The paste just drags on it. You have to have very even heating and perfect paste deposition.
Yeah.
It has to be like perfect.
And so if the component's not placed properly, or the solder's not placed properly, or using the wrong kind of solder, or the heat flow, as you mentioned, like the heat profile is not perfect, then basically it looks like, if you can imagine a little surface mount resistor sitting on a circuit board, but when the solder was melting inside of the oven, the surface tension on one side, one of the two balls of the resistor,
Because it heats up faster,
Yeah.
or one has just more thermal mass than the other.
and so it actually lifts up, like kind of like
Yeah.
a cantilever. It lifts up the resistor, and so now it's kind of poking up, and it looks like a tombstone. And it's a very appropriate name because when you see the circuit board with
And, like, half
a
the boards, yeah, I
it
know.
is like the most depressing feeling imaginable.
You can
'cause-
fix it if it's 1 or 2, but if it's a lot, especially 0201, because then you have to carefully solder it down. It's just very time consuming. And so I think so. You know, it sounds like on the simpler board it would have been okay, but this was just you went in with the toughest design.
Yeah, and to make matters worse, we had most of the company's history we were been profitable,
Yeah.
which is fantastic. We were completely self-funded. But in 2013, we actually took out a SBA-backed loan, or Small
Okay.
Business Administration-backed loan, and to fund new product development. And so we actually went negative for all of 2014 and part of 2015. With the idea that we were going to ship this thing, and then the sales from these new products
Yeah.
would bring us to be positive again. But then we have sort of a runway, like a limited amount of time before we run out of savings
Yeah.
to build and ship this thing. And we originally had part of that cash set aside to pay for initial manufacturing, but we burned through that runway, and we were like, okay, well, we still think we can do this, but now we don't actually have any cash around to build the first run, right? How is this even going to work? And so we did a pre-order, where we launched a pre-order, and the
I'm getting heart palpitations.
I know, yeah, it's so
No, I know you gotta do what you gotta do.
right, and that describes the situation quite perfectly. There's a lot of crying involved, but the so we took pre-orders.
Was this a Kickstarter or an actual pre-order?
Pre-order on our website.
Yeah.
And because we needed the cash in order to build the circuit boards, in order to ship them.
Yeah.
And so we were collecting pre-orders, and of course, the moment we announced the new products, even though we were still selling the old products, sales dropped off.
Yeah.
So now we're not actually shipping any physical goods. The pre-order, let's see.
Just it just sounds like it became very complicated. So you know you had this thing, and of course the ending of the story is you would not be able to use this machine. So you know you had some day when a decision had to be made.
Yeah,
Maybe it was you, maybe it was Joe. And what was the decision? What was that decision? Because we'll get through the painful part and just to the end.
Right. So we're the peak pain point is working 100 hours a week in this like warehouse on this pick and place machine, like building circuit boards at a rate slower than is necessary in order to keep up with demand.
Yeah.
And and the worst part is not only we have this SBA-backed loan, which the government will back part of it on. We had some other loans as well, which we were personally.
Your name
on
on,
the
yeah,
wire for.
no.
So
There's no such thing as
this-
they're
this-
like, oh, your corporate liability. No, your name is on
exactly.
it.
So basically, what was going to happen if it wasn't for like a half a dozen amazing individuals, we would have gone under. I would have declared personal bankruptcy, and it would have been that would have been it.
But you're still
January.
here. So what happened? You just finished enough of the run to fulfill all the
So we
backers?
were
Or
they were
the-
trickling out, which was good. Thank God. So we were actually shipping, and now we were in a much better position because it wasn't like a hypothetical product. So we have a product, we are shipping it to customers, and we have a huge pile of orders.
Yeah.
Like it's just building up every day. People are wondering where this thing's.
And you have a design that you know works. It's actually
Yeah.
the most stressful part. Like at least you didn't send out 10,000. Turns out there's like 4 flaws in it. You have to send them all back and rework them.
Yeah, we
So
need to
then-
rework the first 500 or so.
Well, you know, that's always it. But then you decide, okay, we can't do this anymore. We have to get a partner.
Yeah, and so fortunately, so one of the companies that we had been working with were local manufacturing before. Absolutely love them. Is Sparktron.
Okay.
They're located in Fremont, California, not too far from us. And we were originally thinking about having them build our initial runs.
Yeah.
We just could not afford it. It kind of just
Yeah.
broke the profitability of the product. But they're actually a wholly owned subsidiary of a company in Taiwan called OSE, and they were doing the math and talked to us and said, hey, if we do the entire box build for all of your products, like end to end,
Yeah.
like we'd love to take you on as a
That
customer.
would make sense for us because there's enough labor.
And
Okay.
the price was, and the biggest thing too was that they agreed to extend us credit so that they give us net 30 terms immediately, and we wouldn't have to establish that credit over
Okay.
time, which can be challenging with overseas manufacturers.
Yeah.
And so that was good. So now we have a solution, but we still need cash. And so we did two things. One, we raised our prices about 20%
Okay.
because just even with this new solution, it was just like, wow.
Yeah.
Even if we solve this, we're still in trouble.
Yeah.
So we raised our prices a little bit. We sent out an email to our customer list explaining why, and then linking to a blog post that goes into more detail, which was sort of the something's not going right.
Yeah.
That's sort of the public side of it. And at the bottom of that blog post, there was a link to a page saying, hey, we're interested in raising debt financing. If you'd like to loan us money, please let us know.
Okay.
And thank God for that. That was just amazing. We had probably over a dozen individuals interested. Six of them ended up committing between $50,000 and $100,000
Oh, interesting.
loans.
So you actually did sort of like small scale loans from your customer base.
Yeah.
Some of which are probably well off engineers who are like, I believe in this product enough that I will
Yeah.
I will
In fact,
invest in it.
That was like the best part because it was like almost sight unseen. Like these people were,
Yeah. They believed in you. That's so cool. Is this emotional? Okay. Well, I think it's good. I mean, you're I know this is intense because you're your family, and not only is it like your family, but it's like really your family. These people, their jobs on the line. You're designing this product. You know it's good, and you're just like you're at the lowest low. But the engineers came in and they said, "We believe in you. We trust you. We're going to help bail you out." And you're still standing. I'm still standing. I think that song. But I think it's amazing. It's what I wanted to ask you because it seemed like a really amazing story, and I've always. Watching those blog posts from you and from Joe, I've actually always had a soft spot for the grittiness, the ability of you guys to be like, we got this zebra printer, we're shipping orders. And
Oh,
I'm like,
that's right.
And I'm like,
Oh, my goodness.
yeah, like that's it. This is it. It's like it's gruesome. It's just like you're down in the dirt. You're like reworking 0201s, and that's what it takes. It's that hustle. It's that that heart, and I think you guys really have it, which is really important. And it's how you made it through one of the biggest challenges of your life. I mean, hopefully there won't be more like that because it's a very intense story. But I think people, everyone knows Saleae. I'm gonna have to remember to pronounce it right. The logic analyzers are the best, and there's the best people behind it as well. So thanks for coming by.
Yeah, thanks for having
and
me.
telling me this in story. I feel really inspired, and thank you for everybody who supported them. Y'all are the MVPs. So where can they go to pick up a Saleae?
Yeah, so you can grab it from Amazon or from our website, Saleae.com. And let's see, if you already have the product, I recommend checking out the alpha software.
Yes.
I think about 38 people are using it right now, so it'd be great. We're going to start.
Is it like a free sign up? You just can download it and try it out?
Yeah, it's just you don't have to sign up. It's just really buried.
Okay.
We're going to be pushing a lot more people to it.
Okay, so secretly
early next month.
find the treasure of the alpha software, download it, and what's some of the things that are better about that alpha software?
So the alpha software has, and it's still pretty rough, but right now it has analog real-time triggering for the analog products. So if you have a Logic 4, 8, Pro 8, or Pro 16, you can turn on as many analog channels as you want to, cross your fingers. It's fairly high performance, but it can't quite keep up under all the circumstances yet. But if you actually, and you can't find the feature, we still need to work on the discoverability. But on the channel label, you just click the little expand button, and it will actually show you a scope view with the trigger line. You can drag the trigger line up and down, and it'll actually real-time locate and display the last 1 second's worth of triggers that were detected. And then you can zoom and pan analog vertically and horizontally. There's a lot of improvement left to be done,
Yeah.
but sort of the core of it actually is
Try
working.
it out, and then there's that button where you can press it, and it'll go into Slack channel if you find a bug or
Oh, that's
something you
right.
like. All right, so the Saleae, I use this all the time, debug SPI, SD cards, I2C. Reverse engineering, it's my favorite because, I'll take 2 traces and then I can compare them real easily. So I use mine all the time. This is why I have this handy. But thanks for coming by and visiting. I hope you enjoy your trip in New York.
Oh,
Have a good
thanks.
weekend. And people, if you don't have a Saleae, go to Saleae.com and check out their awesome logic analyzers. It'll definitely save you time, and time is money. So it'll save you money in the long run. All right, it's me, Ladyada, with me, Mark Garrison from Saleae. Now you know how to pronounce it. Thank you for watching this video.
Thanks.
Bye.